Okay, okay, thank you. Thank you.
Prakash sir will start, sir. Let the participants join. Prakash sir, can we start?
Sorry, I was muted on multiple locations. Whether you can see my screen, Ravi?
Yes, sir. Yes, sir. Can
Okay.
see it, sir. Can we start, sir? We'll start
Yeah,
now.
yeah.
Good morning, participants, and warm welcome to the third day of ATAL FDP on advancement of battery management system and its application. It gives me immense pleasure to welcome our today's resource person, Engineer K. Prakash sir. On behalf of the management, principal, CE sir, head of the department and organizing committee, I welcome Prakash sir for this wonderful session. To introduce about our resource person, Engineer K. Prakash sir is having around 15 plus years of experience in design, manufacturing, erection, and commissioning of electrical equipment. Worked majorly on thermal power plant construction in various parts of the country. He worked in various companies like Enercon, ABB, Adani, IL&FS, Hitachi, ABB Power Grids. Presently, he is working as project manager for development of transformer intelligence products. His field of expertise is on design of electric equipments of thermal power plants, manufacturing and factory testing of power transformers, project management, and product management. It gives me immense pleasure to welcome you once again, sir, and I request you to take over the session. Prakash, sir.
Yeah, thank you, Ravi. Thank you, even thank you for providing the opportunity to interact with everyone, maybe through Pan India. Good morning, all. As I said, I'm Prakash. I'm working for ABB Hitachi Power Grids presently. Maybe this topic it is new to me. I put across all those slides based on my experience, which I had. In my previous industry, generally we use batteries because I worked in a thermal power plant where we will be very having a huge battery system in our plants, and based on that, actually, I come across multiple batteries in my career. So I thought of putting in combined inputs from my end on specifically on nickel cadmium battery, which presently we are using nickel cadmium, and mostly initially if we see in power plant we'll be using lead acid batteries, and presently it was phased out and we are using nickel cadmium battery mostly. Maybe to who mostly everyone might be knowing about the battery nickel cadmium. So If anyone knows, maybe it might be a refresher session to you. And if anyone unaware of nickel cadmium, maybe it would be a good session to you. And actually, I apologize maybe to Ravi and also to KPR team, because I had a limited time. I was been traveling from here to multiple locations in past couple of days, so I had limited time to put across slides. Maybe I can share my experience related to the battery and battery management systems in the slides. Maybe if it is not in the slides, I can explain with the documents which I have. So I thought of starting with the different batteries which we have in markets, and why I specifically said about nickel cadmium. Maybe if you see in the battery market, lead acid, it is known to everyone because we use in day-to-day life, and even in our cars and homes we use lead acid batteries. And lithium ion, because as we use in EVs, the main maybe the champion in battery, it is lithium ion, because of it is less weight and multiple advantages which have in lithium ion. But if you see industries, heavy industries, even presently, if we see maybe we have a multiple industry revolution or multiple revolution in batteries. Even as I said, I work in a power plant where we used to have the lead acid battery for UPS and DC charger system, where during maybe phase out or during a block out, we'll be using the huge battery system to operate the thermal power plant equipments maybe for 6 or 7 hours continuously. So initially we had a lead acid battery in most of the power plants, but I hope for past 6 or 7 years we are using nickel cadmium battery as the alternative for lead acid, because it has lots of disadvantages. Like nickel cadmium, it is an alkaline battery, and lead acid, it is an acidic battery. And nickel cadmium has maybe the maintenance, it is less. Maybe I have separate slides for each and everything to represent. And lead acid, if we see maybe the maintenance, and we need to regularly monitor the battery, and maybe we need to add a distilled water, multiple things which we need to do at lead acid. But nickel cadmium is not like that. So few factors which I can say, that we can charge the battery at higher speed, not like lithium ion, but nickel cadmium, it has an a much advantage than the lead acid battery. And the very good difference is that it can operate at multiple temperature ranges, even at lower temperature range. We can see that -40 to 60 degree, where lead acid starts from 20 to 60 degrees. So that is a prime one which we have. One the difference, it is that the cost, it is slightly higher in nickel cadmium, but if you say overall as a battery bank, the cost of maybe the operation cost or cost per cycle or replacement of battery and nickel cadmium, maybe if you see, we can operate for more cycle life than the lead acid battery. So in overall 20 FEC, we may need to replace the lead acid thrice, but nickel cadmium, we may need to replace it twice. And that also, if we operate the nickel cadmium battery on the manufacturer specification, and maybe at specific charge and discharge rate, I hope nickel cadmium has a much advantage than the lead acid battery. And I concentrate on nickel cadmium because presently, maybe if you see the grid, we have solar system, we have wind, everything, and presently even in India we come across as SI, wind with ABB and Hitachi. Basically I work on power grids where we know about I operate on 1100 kV to 400 kV and 220 kV system. But presently, if you see, there is no major construction on switchyard and everything, because industry is moving towards microgrids. That means even in I belong to Coimbatore, where I see multiple textile manufacturer, they have their own solar system and a battery system for it. And I heard multiple location, mostly everywhere. Maybe 50% they use lead acid and 50% they gone for nickel cadmium. So it's where we need to have the battery system to charge and discharge, and maybe specifically on solar, where we will not be having a capacity during night. So I hope nickel cadmium will be the maybe a major source or alternative to lead acid, and hopefully presently even as I said, in power plant we phased out lead acid, and presently we have the nickel cadmium. So that is an update or general guidance which I have towards a nickel cadmium. And if you see, there are a few things like cell voltage, it is 1.2 volt, and it has one disadvantage than lead acid, that is the self discharge of battery. It is 20% per month, so that is a major disadvantage for a system if it is in ideal. But most of the cases, if you use a storage system, hopefully it will not be an issue for day-to-day cycle. So that is a general update on comparison. We have a detailed comparison on all batteries, but specifically I compared lead acid and nickel cadmium, where we see much growth on nickel cadmium on industries than in lead acid. If you have any queries or questions, maybe and actually it is based on my own exposure on power plant and exposure on batteries which I had, and I didn't take up much theoretically. Even I thought of doing it, but somehow due to time availability, I didn't take up much in detail on it. If anything wrong, maybe please guide me on this, or if everything is okay, please update me so that I can proceed further. Do anyone has any queries or questions related to it? If you have any queries or questions, not only towards nickel cadmium, or if you need any questions related to battery management system or batteries in industries, I can update on that part. Ravi sir, please update me if there is any comments on chat tab so that I can update, because I have only one screen today, so I'll be concentrating only on the presentation. Thank you. Actually, maybe as I said, mostly everyone might be knowing about the nickel cadmium battery, or maybe if it is a new to you, maybe I can update on the construction of nickel cadmium batteries. Mostly each manufacturer has the similar construction. I had in India, we had bought battery from HPL, and also we bought battery from Alcat from Sweden. So mostly it looks similar, even construction dimensional wise for same AH, the battery size are same, and mostly the construction also same, where positive plate it is nickel hydroxide, and negative plate we have a cadmium electrode, and separator they use a micro porous polymer, even in most of the batteries they use. And the electrolyte we have potassium hydroxide mixed with, and maybe it is around 3% of lithium hydroxide mixed with potassium hydroxide. So and as I said, maybe I move towards the anyone has any queries or any update, maybe I can guide on it. Thank you. I'm proceeding next. Maybe actually generally every battery has its own electrochemistry in it. Similarly, nickel cadmium, as I said, we use nickel hydroxide as an active material for positive plate and cadmium hydroxide for negative plate. And electrolyte, as I said, it is a potassium hydroxide. But if you see in lead acid, the ion exchange takes place in the electrolyte. But here, the electrolyte is not used to, maybe there is no chemical process involved in the electrolyte, even during charging and discharge cycle. So if you see the chemical reaction, we are aware during discharge, trivalent nickel hydroxide is reduced to trivalent nickel hydroxide, and it is in positive plate, and negative plate it terms as an cadmium hydroxide. So that is, and if you see the charge and discharge cycle, it is equated. So only, as I said, in nickel cadmium, reaction is positive and negative, so there is no change in electrolyte level, or because when we charge or when we discharge a charge, it delivers water, and it consumes water. So if we charge the battery as per the manufacturer specification or charge cycle, there will not be much chemical reaction or the electrolyte consumption in nickel cadmium. So that is a major one. For example, if lead acid every month or maybe every month or every quarter, based on the battery operation, we used to top up the electrolyte regularly for lead acid. There are a few batteries like sealed batteries, sealed lead acid battery, where it doesn't need, but mostly in industry we will not be using the sealed one specifically. So as I said, here the chemical reaction, it is clear that there is no need of updation of electrolyte. we need to update after a few years based on the battery loading cycle and also the operating parameters. So I have few slides on it. So this is the chemistry which we have behind the nickel cadmium battery. So I thought of comparing few technical specification related to the nickel cadmium battery, basically on the capacities, different cycles and comparison between batteries, and also the temperature. Actually, even at industries, if you see the battery or battery storage room where it would be a controlled environment where the operating temperature would be plus 20 to 25 degree, not more than that. Where even not only nickel cadmium, all batteries operate much better on specific temperature, that is 20 to 25 degree. So even you can see here that the storage capacity, maybe you can see that the available capacity decreases based on the temperature. There is an increase in temperature, and it is very good at normal temperatures. So that is the loss. As I said, nickel cadmium battery, it has much open circuit loss because the resistance which we have internal battery is much higher than the lead acid battery. So only this one, maybe if you see in a month, we'll be having a 20% of discharge. Sorry, not in a month. If you see in the long run, so it is a comparison for maybe. I hope in a year the battery would be completely drained if it is left open or during ideal condition. This is a major advantage of a nickel cadmium battery, where we can say that if we operate at specific operating parameters like a charge and discharge at specific manufactured specified value, we'll be having a much higher cycle efficiency. Even though if we see, for example, one cell of lead acid we can buy at 25 USD, but nickel cadmium costs around 50. But lead acid we need to replace maybe around 6 years or 7 years once in a thermal power plants. Nickel cadmium it may go for 12 or 13 years. So if you see the operating cost of nickel cadmium, it is much lesser than the lead acid battery, or maybe the cycle life. It is good at nickel cadmium. Here we have the comparison of temperature. Again, it is a very good comparison against lead acid. We can see that a nickel cadmium battery has much what is it good operating parameters with the temperature than lead acid. As I said, there is no maintenance required for nickel cadmium at regular interval. So if we see, maybe we need to fill or add water to the batteries if it operates at 40 degrees C, maybe in every 5 years. And if it operates at the specific temperature, the 40 degrees, so we don't want to have any maintenance till 10 years. So this is a major advantage, where we don't want to have any people on monitoring the batteries or maintaining the batteries. So it gave an advantage over lead acid, and now everyone turns towards nickel cadmium batteries. And again, here actually the available capacity based on, there are multiple types of charging available, like float charge, boost charge, double boost. Maybe it is a term which generally used by laymen. Basically, it is a two different voltage charging method which we have in the charger. Maybe we can select not based on cell voltage. It would be combined. If it's a 220 system, generally we charge it 10% extra. Maybe it would be 243 volt basically, or even some manufacturer they prefer to go till 265 volts. So if you increase the voltage, the available capacity increases mostly. But generally at industries, they will operate the battery range from 80 to 40. That means we will be consuming the battery only with the 40% of it. And few cases they will maybe here the cell voltage of nickel cadmium is 1.2. So manufacturer prefers to discharge the cell till 1 volt. So that is a factor. Maybe for generally in 220 volt DC system, we would be having 243 volt or even 265 volt. As an additional voltage to have some cushion on the battery discharge. So based on that, actually, even we design the charger and we design the battery bank capacity and number of batteries and everything. It's based on the requirement of equipment which we are using. Like numerical relay has its own specification. Motors, DC motor has its own specification. So based on that, all this factor would be considered. But general practice, we will be operating the range between 80 to 40. Actually, if anyone has any queries or questions, maybe I can add up to it. I have a slide where I thought of discussing in detail because I thought of comparing the system which we have in India and globally. And also maybe it would be a good one if anyone takes up or maybe does a detailed project on that specific part. And actually, even nickel cadmium battery, generally in lead acid, we used to measure the density of electrolyte, but in nickel cadmium, it is not required to measure the density at all because based on the temperature and based on the operating parameter, the density varies a lot. So we will not be identifying anything on density. Basically, in lead acid, we will be identifying the density and check for electrolyte update. Or maybe there are further consideration on it. But nickel cadmium even and that is not there. Only point is that we need to monitor the cell voltage, charging current, discharge current, and the bank voltage and bank capacity and everything. So as I said, the available capacity based on and most of the manufacturers specification, maybe we have it here. C5A basically it is a percentage. Generally they say it as 0.2 C5AH. So in 10 Ah battery we maybe we would be charging at 2 ampere per hour, and mostly the charge cycle they used to say it as we need to charge minimum 7 hours. Most of the manufacturer prefers same, but we can see that current limit is 0.2 C5A. Maybe I spent some time. Actually, I thought of putting some what to say drawings, templates regarding this, but maybe as I said, due to my travel plan, I didn't had some sufficient time to add up. Maybe I update a few things which I come across in the industries. Maybe if you see in battery management system, we would be having a bank, even a data center, or a companies where they have a UPS system. Like maybe IT park or maybe some IT offices, maybe a big offices. And right nowadays they have a UPS system, not with a single battery. Maybe it is bank of batteries which tied to it. So measuring cell voltage, it is not a big engineering which we need to do on measuring cell voltage. Even still nowadays, even still I see people generally power plant or any plant runs on shift. Every shift people used to go and measure the cell voltage of each and every individual cell at regular maybe at every shift, or maybe in every day. Based on the industry they will measure the cell voltage, because this is the main parameter to monitor the battery. Because the battery may open, or maybe say it would be around lesser volt because of change in chemical parameter inside the battery. So for monitoring this, we will not be knowing. For example, even there is an maybe if a technician doesn't monitor this cell voltage properly, even it would be a catastrophic failure for total battery management system. We faced this. As I said, I worked in thermal power plant where if there is any blackout, maybe for example we are operating in 400 kV system and we would be connected to the grid. And if there is any issues in grid, first thing it would be there are multiple prime running motors, or maybe we have loop oil skids, multiple things which runs on DC power. And also UPS feeds power to multiple stations like DCS and everything, where the battery management system plays a major role on monitoring. So if anyone leaves unmonitored the cells, even I personally had an issue with one of the unit. I work for Adani, where we have the South Asia's largest power plant, and I hope it is on 2011. I hope where we had the total blackout, not in South. In north, the power was not there for around 12 hours for around 6 to 7 states. That is because of this battery management system, where we didn't even had a DCS screen at all. The turbine is running, and all the motors, DC motors, everything running. And the operator, shift operator, they need to control the power flow, and also they need to control the generator, turbine, and everything. As the UPS system, it is not operating. There is no screen for us to operate. Because of that, around 3 or 4 turbines, they maybe switched on emergency stop. So that raised an again a power swing, and we caused a complete blockout in northern grid. So I see few people from north, they might be knowing the 2011 where we had a big issue on the blackout. It is specifically because of the emergency power system. It is not taken up, and there are multiple reasons on operation side that it is different. But the battery, it is the main system nowadays. Maybe it is a prime for power plant. Likewise, as nowadays, as I said, the industry is moving towards microgrid, where I have my own solar cell. I will put a battery system, and I will be operating my own equipment at night. So in that case, if there is a failure of single battery, it would be an open one. It will not impact much on your operation. But if it is not monitored at regular interval, one battery fails, it gives an impact to the neighbor batteries. So it would be a regular failure, and if it is not monitored completely, someday you will not be having any system running. So the measuring cell voltage, it is a simple system which Chinese has in their portfolio, and also nowadays there are big competitors where we have, but still in India we are not having the specific battery management system, which I say. Basically, we have a positive and negative plates. Maybe if you see, generally we have 170 cell system for 220-volt battery for nickel cadmium. It is because it is 1.2 volt, and maybe based on voltage, you can calculate the number of batteries we have in a battery bank. The system is simple. We would be having a positive loop to a small module where it measures the voltage. For example, in nickel cadmium, it is 1.2 volt. So measuring at 1.2 volt, it is a simple electronics which we need to have near the battery bank. So all positive would be looped to the battery bank, and the negative end terminal would be looped to the battery as a reference. So with a negative reference, it would be measuring the voltage of each cell. So that is a main prime factor which shows if there is a battery open or if there is an issue in voltage, then it give a clear indication to the people who sits in a control room stating that this battery has an issue. As I said, still around 70% of industries which I monitor, they use to have the manual system or manual measurement system generally. So this case, maybe it is not a big engineering one, it is a simple engineering one. Maybe anyone can propose the system or take up this as a project and take up on this. So cell voltage, it is and maybe if it is multiple bank where they have an Modbus TCP communication between the module, and they taken up some engineering in it and taken to the central control room to monitor the all voltages of all batteries. So that is a one prime one which we are not having in our country. Basically, there are a few MNCs which they have. Because of cost and considering multiple things, no one prefers to go for it basically. So that is one factor which we need to monitor regularly, and it is a prime factor in battery management system basically. And the second one, cell temperature actually. Hello. Yeah, sorry. Measuring cell temperature, it is a second parameter because, as I said, maybe in lead acid, I have seen a battery blast because of increasing temperature. And maybe there is some, because there are lots of chemistry behind it, and battery temperature reaches maybe from 40 to 50, 55 degrees at some interval, maybe during regular operation. So the cell temperature also need to be monitored regular interval, which mostly it is done manually in our part of the world. But even I had good interaction with Europe, and I also been with Europe, where they have a very good monitoring system on temperature for cells. Just it is a simple RTD mechanism where they have one separate, maybe in the same cell itself, they have a small pocket to measure the temperature. It is a mandatory in Europe to have the cell temperature measurement in the batteries. And next prime factor, it is the charging discharging current. It is not on cell. It is primarily on charging, because we have multiple chargers or different charging mechanism which we have. Even in EV also we have, where the charging and discharging, it is maybe the charging it is good in EV, and the discharging it need to be monitored in banks, as I said, as specific on industries. This need to be monitored at regular intervals. So even every shift they have a specific plan for charging and discharging, and also it is a prime maybe monitoring parameter for batteries. And the final one, it is the battery bank voltage. It is not related to battery, but it is related to the operating equipments. As I said, maybe there are voltage limiters. It would be there between the equipments and the battery. But the battery bank voltage, it need to be monitored closely, because, for example, if you have a few for example, as I said, we have 170 cell of 1.2 volt, it would be around 243 volt mostly if we calculate. So if few battery fails, it will not impact even the system. So only we would be operating continuously. Suddenly, if 10 battery fails, then you would be losing 17 volt of it. So this is a major point where we need to monitor the cell voltage. Parallelly, we need to know the battery bank voltage, because numerical relays or motors which we have, it operates on specific voltages. So as battery is an emergency system, this also need to be monitored closely. So these are the four factors which we have on battery management system. Other than that, we have a different, what to say, charging cycle, different consideration towards the battery charger, which it is an elaborated topic, and I thought of having some information on it, but maybe I can put across this in the slide, and I can share it with the participants shortly. Do anyone have any update or point, maybe an observation on my discussion? And this battery management system, it is specifically same for all batteries. There is no distinction between batteries. This one, it is same. The charger and everything, it is same. Even nowadays, manufacture the battery charger, maybe manufacture, they have settings for different batteries, and we can toggle between different maybe battery type. So we have an option on it. Actually, maybe as I said, I consider towards the nickel cadmium batteries. There are lots of advantages in batteries, where it has a very high energy density and it has greater storage capacity. And if you compare the cost, it is low, because not of the initial cost, it is about the running cost or the cycle cost, which I discussed. Second one, as I said again, nickel cadmium has a greater recharge cycle life than the lead acid batteries mostly. That is the way where the industries are moving towards the nickel cadmium batteries. And actually, one maybe point, specifically when battery, they say the battery memory, generally they say it as battery memory. Even if you use on our phone, generally we used to say to charge the battery at full and discharge till the end and utilize the battery, where it gives a good life of battery. Similarly, we have similar, if it is a normal duty cycle, nickel cadmium will give a very good life. And again, I said, if it is a normal cycle, the consumption of electrolyte will not be there, and even there is no need to go for maintenance if you have the battery management system installed in the nickel cadmium battery. So it reduces the complete work cycle of a station. And actually, it has a long shelf life. Even we can store this battery for a long. And and as I said, it operates on different temperature maybe minus 42 plus 60 degrees. So it gives a very good variant. Even it can operate in our region, Asia Pacific, and also Europe or in US. So it also have a very good temperature performance on it. I updated the cost basically. And another one major factor it is that shipping and battery. For example, we ship batteries to multiple countries from India, and also we also import lots of batteries from other countries. So there are lots of restriction to ship lead acid battery and a few other batteries in the pipeline. But as it is an alkaline battery, there is no restriction to airship everything. So that is one major advantage which we have in nickel cadmium battery. Even that is the main reason we've gone for nickel cadmium in our plant. Actually, one limitation as is it has a high energy density, but it is comparison to the lead acid. But when compared to the newer system, this is the one which it is not competing against lithium battery, relatively low energy density. That is newer system. It is the lithium ion batteries. And this is the main factor. It has the memory effect. It is the same for all batteries, but in nickel cadmium, it is specifically if you overcharge or over discharge, maybe it is a major. It gives a major impact to nickel cadmium battery. So we need to operate the bandwidth between 40 to 80, where it gives a very good life, basically. And as I said initially, it has a high self-discharge, which we need to consider while designing the battery bank and battery capacities. Actually, maybe I thought of having a big session for today. Maybe not only batteries. If anyone has any point to discuss, maybe I can discuss or update on it, or maybe if anyone has any point to discuss specifically on battery, maybe we can utilize this as an open forum and take up. We can have a good discussion. And maybe I apologize from my end. As I said, I was been traveling, maybe due to my business priorities. One of my teammates got infected with COVID, so I was being forced to travel to Delhi, and also I've been back to my native maybe a couple of hours ago. So I had a very less time to prepare the slides in detail or add up more content to the slides. Maybe there is some.
Sir, good morning.
Yeah.
Sir, am I audible?
Sir, actually, I can't hear you clearly. Maybe. So if anyone has anything, maybe I can update on it. Maybe actually even we have those. Maybe it is out of topic. We have multiple charges in ABB. I've been part of it for a while. Maybe it is called as DOSA, where we right now we have an tie-up with IIT Madras to take up and have it in multiple locations in India. Yeah, that is related to EV. Maybe it is a separate topic. And actually, it's not from my end. If you have any queries or questions, maybe you can ask. Even if I have an issue, maybe I can take up with my team or internally, and I can update.
Sir, good morning.
Yeah.
Hello, sir, I'm audible?
Yeah, good morning. Yeah, I can hear you, sir. Good morning.
Yeah, this is Uttarasamy, sir, from KPR. So I'm having one basic doubt. Normally, if you are designing a battery system, normally we prefer the lithium ion only. So take as an nickel cadmium or lead acid battery. So go for a lead acid battery, even though it is cost is less, the power density is cost is less. Power density also not that meant appropriate for EV vehicle applications. So what is the right choice of a battery system for EV vehicles? If students want to
actually, sir. As I said, for EV, as you updated clearly that the power density over lithium ion, it is specific. So only industry is moving towards lithium ion than nickel cadmium. If you see, initially in few countries they use nickel cadmium as an alternative for it, and because of that power density, it is no more used. But lithium ion, it is not possible to use in industries like power storage and everything, because it costs much higher than the nickel cadmium. My point or towards it is related to the industries where EV, it is a small part. Maybe it is on mobility, but there are lots of things for EV. Even if you see, there are multiple storage systems in Europe. If you see, we would be having a solar panel installed near the EV stations, and it would be powered through solar. So for that, they would be using the nickel cadmium battery for storage. Even though basically lithium ion is used as you said, it is on power density, and also the weight factor. Lead acid is much bulkier, and if you see nickel cadmium, it is lesser. And if you see lithium ion, because the performance of car, it depends on weight of a car. So only they are considering lithium ion. But nickel cadmium, it would be a preferable solution for storage system. As I said, microgrid, even in ABB, we have a separate division for microgrids where nowadays, if we see, we had a HVDC where power transfer from one country to another country in Europe, and also if you see in India, we have a very good corridor of HVDC station between multiple states. But presently, for example, as because of solar, grid became micro. That means if I am in Coimbatore, for example, in Tamil Nadu, maybe we might be having some multiple solar panels installed in some of the locations. So we'll be using that instead of transferring the solar power from one district to another or one state to another, we'll be utilizing then and there with a battery bank. So for that, if it is a battery bank, it would be a nickel cadmium with the preferable one for run big storage stations.
Sir, I need one more clarification. So normally, if you want to make a lithium ion to meet maximum, that is a starting torque demand, normally super capacitors and ultra capacitors are parallel with the lithium ion. Is this facility is possible for nickel cadmium also?
No. Sir, as I said, I'm not specific with EV. Maybe at this point I can check and update because even I didn't gone into EV in detail because it is not what to say my part of
no issues. Okay,
activities I have.
Thank you, sir. Thank you. Okay.
And actually, maybe EV, it is even I had multiple questions from multiple colleges related to EV, as it is a booming topic all over the world. But I am specific to the power industries and battery storage system. Sir.
Okay, sir. Thank you. Thank you.
Yeah. And I have maybe ma'am Ratika again asked the same question. Specifically, I saw the agenda and mostly everything it is related to the EV, but I thought of having a different thing because I thought of updating on nickel cadmium so that not only battery has major factor on EVs, it also has a major impact on storage stations. Even we can see that in Europe there are lots of container systems, plug-in containers. For example, we would be having multiple, maybe 10 from 10 Ah to 100 Ah, 200 Ah. Even we have a 2000 Ah container system where just we need to install solar panel and plug in the mechanism. We do the charge, discharge, and also it monitors everything by its own. Sorry, I'm not presenting, sir. Actually completed my slides. I have various slides today to update. If anyone has any point, sorry, maybe I might be having there are multiple people I see maybe experienced than me to update. So maybe if anything related to power industries or anything, maybe you can ask me because I am from power background. So I can update on that part also. So do anyone has any queries? Maybe I hope I had a less information, but I put some spike or inputs to you on nickel cadmium batteries. Ravi sir, I hope it is completed from my end. Maybe I have one more queries. So actually, yes, ABB is looking at maybe right now. ABB, if you see specifically on EVs, ABB has a tie-up with IIT on charging stations all over India, considering, and also we have tie-up with Ashok Leyland on EV basically. Actually, for colleges, I hope presently ABB has considered to IIT, and I don't know from which college you are, sir, and maybe that thing I can update. I check and update parallelly. So thank you, sir. Maybe I can. I will be sharing my contacts, so I can get connected to you, and I take up with the appropriate person. I will update you on this. Maybe as is updated initially, I've been working with the wind, solar, mostly on thermal, and presently I'm working on transformer intelligence product where industry move towards 4.0. We've been developing multiple products on transformer monitoring solutions. And if anyone has any other points, generally on power industries or general topic, if I know, I can update, or otherwise. Maybe I can check and update you shortly. Maybe I thought of utilizing this opportunity to get connected to people. Well, sir, thank you. That's all from my end, sir. If anyone has any queries, maybe I can update, or maybe I hope I didn't utilize the time 100% because of few other things. But I hope I gave some inputs from my end. Hello. Ravikumar, sir, you're on mute. Maybe I need a guidance, sir. Maybe as there is no queries, maybe we can wind up the call from here. If there is any queries, maybe I can address.
Sir.
Hello. Hello, sir.
Hello. Yes, sir. I can hear you.
Sir, can we connect a supercapacitor with a lithium-ion battery for sharing of the peak power?
Sorry, as I said, actually, I was not been with the lithium ion, maybe on EV and anything. So I mostly worked on lead acid and nickel cadmium batteries. So basically, I am from power background and utilized for battery storage system. And lithium ion is the one which we used in EVs, basically, sir. And it is completely a different industry to me.
Okay. Thank you.
Thank you, sir. Maybe I hope we lost Ravi. I don't know if someone from KPR. I don't know. Maybe I can check for the people available. Ravi sir, you're on mute. Maybe I see Kumar Chinian sir also. Sir, how to proceed on it? I actually completed most of the points from my end. Sir, I completed the slides and I hope there is no queries.
Okay, sir. Participants, if you have any doubts, you can ask. Otherwise, we'll wind the session.
Your voice is so low, sir. Maybe I can't hear. I don't know about others.
Participants, if you have any queries, we'll answer to it or we'll wind the session. So since there are no questions, I take this opportunity to thank our today's resource person Prakash sir for his insights on lithium-ion batteries, lithium-cadmium batteries. And I take it a pleasure in thanking him again and all the participants for being in wonderful audience. Maybe we'll meet in person next time, sir. We'll end the session now, sir.
Yeah, thank you. Actually, maybe as I said, I apologize for not utilizing the time 100%, and thank you for everyone's time. I see multiple people from multiple location India joined. Hopefully, maybe I utilize some of my time today to put across some my experience. Some